This is ETE 130 Practical Test 2 with Paul Prey and Thaddeus
Beetle. Here we were given our control logic ABD, or not ABD, or not CD, or not A, not C, D. And to simplify that using boolean algebra, we first started off with the absorption law, which would bring ACD into CD since not A isn't needed. And then from there you use the distributives to take BD out of these two. And then from there, the not A becomes 1 through the identity law that breaks down further into BD, not CD. Or
yeah, perfect. Then, so we got our circuit we built here. So we also have a little diagram here in the green. You see we have our two ands and our OR, and switch B, switch C, and switch D. You got the inverter there for the not C, which is the only place it's going. You have your pull down resistors, all three 1Ks. You have a pull down resistor going into the AND for the C circuit, and then you have a pull down resistor for the output coming off of B and D as well. Going into the OR, coming across the 390 resistor, that should turn on the LED given the inputs are true. So we can go back to this truth table here. There's really only 3 of them to worry about. We got B, C, and D. Now, based off the truth table, no matter what, if you press D and all given that C is not pressed, so D not C, based off our equation, should always turn the light on. You can see it does. Now, you got C and D. If you press it, it'll return a 0. So you got D on, you press C, turns it off. And then, main thing to realize is if you have all 3 of them, or just B and D, no matter what, that light's going to turn on. So you got D turning on, C turns it off, then B turns it back on. If you let go of C, it's still gonna turn on, stay on, because of the B and D is active. Yeah, that wraps it up.